All right. So we're looking at coordinate geometry. So some basic things that we should remember. We should remember that every graph has a x-axis and a y-axis, right? On the x-axis, what we know about all the points on the x-axis? Anybody? Only if you plus a point on the x-axis, something is always the same. Anybody? Somebody? Anybody else? Dominic? What is happening? Right? What you will recognize is that every single point on this line, y is 0. So if I ask you to plot 1, 0, where would 1, 0 be? Here, right? If I said 5, 0, right? If I said on the other hand 0, 4, where would that be? Here. Okay? So on this line, y is always 0, right? Like cast it out. And on this line, x is always 0. Okay? So on this line, I want you to remember that x is always 0. And on this line, y is always 0. Right. How do we plot points? Suppose I gave you A and I said A is 3, 2. And I said that B is 5, 4. How is plot again? Which one is plot first? What does the first value represent? The x value, and the second value represents the y value. So you plot x is 3, y is 2. And you see where they meet, that's E. Then you plot x is 5, y is 4, about here. That's it. So just one of the basic things that you should know. Now we're going to apply some geometry to all the points. All right, take a minute, draw that. You want to be on graph before you go to your notebook, right? Draw that points. extra bloody points, and then we're going to find something bloody points. Check what check where your potential is getting. Anybody? Right now. Yeah. Right. So the first thing that we're going to try to find, right? The first thing that we're going to try to find is we're going to try to find the distance between A and B, right? So the first thing we're going to do is to find the distance between A and B. So we're trying to get this distance here. So in order to do that, right, we use the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared, right? So we take the x2 value from the x1 squared and so on, right? Right, so it's up to you. You can label it however you want, but for now, I will choose this as x1, this as y1, this as x2, this as y. Okay, I'll choose them like that, right? x1, y1, x2, y2. Nice. So let's work it out. Let's work it out one time. Right? All we're gonna do is just plug the values in. X2 is 5. X1 is 3. Y2 is 4. Y1 is 2. That's okay. That's my paper. Put it out. Sorry, that's it. That worked out. Right, take your time, work it out some more, yeah. Okay, rotate. Yeah. And you can write it if you want to. So. Right? So distance between AB, right, is also the same as finding the length of the line AB. So if I draw a line from A to B, what we found there is the length of the line, right? So you can make a note that this is also length of the line. Right? This formula can also work for length of the line, right? Are you okay with that? First formula to learn, so you can highlight that. Number 2, next thing that we need to be able to do with that same line is we need to be able to find the midpoint. Right? Find the mid. Anybody can guess how to get it from the middle? How to get it from midpoint? Alex, any guess? How could I get the midpoint of AB? Well, I want to get in middle here, right? So if this value is 3 and this value is 2, what's the middle x value? If here is 3 and here is 5, what's the middle x value? What's the middle of 3 and 5? 4, right? So what we have to do is take the x values and add them and then divide by 2. Right? Take the y values and add them and divide by 2. That's okay? That's how you find midpoint. Go ahead, find it one time. Find it one time. Right, next thing. Oh wait, we'll work out this way. So I have 3 plus 5 over 2. And then I have 2 plus 4 over 2. 8 on 2, that's 4. 6 on 2, that's 3. 4, 3 is the midpoint, right? That's the middle. Okay with that? Right, next. This one you may have done it already, but the next thing that we can do there is find the gradient of the slope. Right? The next thing we can do is to find the gradient, or what we call the slope. The symbol that we use for gradient is m, and the formula y2 minus y1 over x2 minus x1. Right? Y2 minus y1 over x2 minus x1. Right? Do you think? Work it out. Right? So the gradient should be done. The gradient will be 4 minus 2 all over 5 minus 3, which is 1. All right. Quick little thing on gradients that we're supposed to know. A quick little thing on gradients. The first thing, well, what type of gradient is this? If the line slope like that. Just like this one, that's a positive gradient. If your line slope like this, negative. But what if your line slope like this? Or like this? What type of gradient is this? All right, let's start with the easier one. What type of gradient is this? Dominic? You mumble it there. Is this line slope? No. So the gradient should be what? Zero, right? This line have no slope. So the gradient is zero. This line have all the slope in the world. So the gradient here is what? Huh? Infinite. Okay? So once you see a line, you should know what type of gradient it is. All right? Make a note of that. Right? So we learned about these three things so far. Fourth, number 4. Number 4. All right, I want to leave this. Why I want to leave this side? Take that one. Online, hello, okay? Mariam, hello, okay there? Yeah. All right. Next, we need to know, you see all those lines that we've been drawing? We need to know, Alex, something called the equation of line. Right? We need to get the equation of the line. So every line, right? I'll draw a general line here for you, right? Every line has a few things. Every line has a slope, and every line has what we call a y-intercept. Right? So the equation of our line is generally written like this, right? The general form is y is equal to mx plus c, right? That's the general form for the equation of a line. M is the gradient, and c is what we call the y-intercept, right? Where the line cuts the y-axis. It's called the y-intercept. Okay? So we need those two things to get the equation of the line. All right? So if we go back to our example, we had A, let's see if we find what earlier. A was what? 3, 2. A was 3, 2, and B was 5, 4. Correct? Right. And we already found the gradient. The gradient was 1. Right? How will we get the y-intercept? Really easy. In order to get the y-intercept, we use C is equal to, I'm just making C the subject here. Let's do that fast, man. Make C the subject here for me. C is what? Right. Alright, so right. So to get C now, all we need is a gradient and any point you want. No matter which one you choose. You can choose 3, 2, or you can choose 5, 4. It doesn't matter. Right? I am choosing 3, 2. Y is 2. M is 1. X is 3. So I'll get C is equal to 2 minus 3, which is minus 1. Okay? And that's it. We're done. Therefore, the equation of the line is y is equal to m, then you write back x, then you write c. Right? So your answer is y is equal to x minus 1. That is the equation of the line. Okay? Y is equal to x minus 1. Okay with that? Okay with that? Copy down quick. All right, so remember to always get the equation of a line. We need the gradients of the line and we need the y. Okay, at all times we need to remember that. You want to stand up and you corner there for half. Ready? All right. So I just want to spend some time on the equation of a line because sometimes we make little mistakes, right? Right. So I'm going to give you 4 lines, and I want you to find the equation of each one. All right. So let's start here. Take your time. You might struggle with 1 or 2 of them, right? But still try it, right? So I'll give you this one here. I'm giving you different types of information on them, right? This one, that point is 3, and the gradient for this line, I am giving you the gradient. The gradient for this line is 4. Right? I want you to find the equation for all, right? Right, let's call this line 1. Line 2, a little different. I'm going to give you 2 points on this line. I'm going to give you the 0.53, and I'm going to give you the 0.97. Okay? That's the second line. The third line to complicate the whole process. I'm giving you a line here. let's call this guy here line 3, right? And this point here is the point 11, right? And then let me confuse up the whole thing here. And this is line 4. Line 4 is passing through a point here -3. All right. So I want you to take your time and find the equations for line 1, line 2, line 3 and 4. 3 and 4 are a little tricky. Some people might know it. Line 1 and 2 easy. Go ahead. Try it and pass it around to watch all. Pass it around to watch all. Online, you can message the equations, right? Right? Go ahead. Find the equations for each one there, David. We should finish already. Right? Remember, line 3 is a vertical line. I told you something about it. Line 4 is a horizontal line. And when you finish that pass around, I want you. The first two should be simple, right? The answers online. For line 1, send line 1 and 2. If you're not getting 3 and 4, that's okay. I'll help you. That's not. All right, let's do it again. So let's start with line 1. So if we start with line 1, you'll recognize that for line 1, I gave you the gradient and I gave you the y-intercept. Okay, so all we have to do is plug it in. So you'll get y is equal to 4x plus 3. Ready, get up? Fishies? Huh? Why? Right, so you have to work it out. Actually, this should be minus 4 because it's a negative gradient. Just for minus there, come on. Right? So I give you the y, I gave you the gradient, I give you the y-intercept. There's nothing to really work out. Huh? No, C is only the y-intercept. Okay? C is only the y-intercept. Line 2 now. Line 2 is what you did last time, right? Line 2 is where you have 2 points. You're going to find gradients and find y-intercept. Y'all did that? And then pass around on what line 2. Right here. Right? So line 2 are using these 2 points here. Line 2 are using 5, 3, and are using 9, 7. Right? So the gradient for these 2 points will be 9 minus 5, 7 minus 3. So I got 1 again. 9 minus 5 is 4, 7 minus 3, 1 again. Yeah. So the gradient is 1. And the y-intercept is y minus mx. So I choose in these 2 points again. Y is 3, gradient is 1, x is 5. So I got 3 minus 5, which is minus 2. So for line 2, the answer is y is equal to 1x minus 2. That's okay? Yeah? David? You sure? Right? Line 3 and 4, everybody watch here. Line 3 and 4, real simple, but you wouldn't have done one like this yet. What is here? For line 3, right, is a vertical line, right? What you will recognize is that if it's a vertical line, every single point here, every single point, the x value here, the x value is 11. Here, x value is 11. The y value will change, but the x value on every single point there, x is 11, right? So what they do is instead of trying to get all of this, they just write the equation as x is 11, right? Because it's a vertical line, every single point on that line is 11, right? So they call that equation x equals to 11. That's okay? So, Vishish, if you had a guess, right? What do you think this line is? The horizontal line. And it's passing through y is minus 3. What do you think this equation here will be? Think about it. This one was x is 11 because every single point on it, x is 11. Huh? What is negative 3? Huh? You sure? Why? Because because this point is y is minus 3. And every single point here, because it's a horizontal line, every single point is y is minus 3. Are you okay with that? Yeah? So these are your 4 equations of a line. Okay, come here now. Right, next thing. Next thing, right? Next thing that we need to remember, we'll do some of these just now. The next thing that we need to remember is that the equation of a line is always this. Right? So we should be able to read off M and C all the time, right? So what's this example here? What's M and C? Alex, what's M and C here? M is 3 and what about here? What's M and C? Right, but the first thing we should do is make it look like this. The first thing we should do with this is make it look like this. Is there any constant on the left side here? But there is one here. So I have to move it. So I'll get y is equal to 2x minus y. Now we could read off M, and now we could read off C. Correct? What about here? 5y is equal to 10x plus 5. What is gradient I'm saying here, Jamal? What is the gradient here and what is the y-intercept here? But the problem is this y is mx plus c or is this 5y is mx plus c? It's supposed to be y. So what to do? Right, so divide everything by 5. So here I'll get y. Here I will get 2x. And here I'll get 1. So everything should be in the form y is equal to mx plus c. That's okay? Yeah. Now we can read off m, which is x, which is, sorry, c, which is 1. Let me get 31. Copy down 1, 2, 3, and try number 4 from everybody. Right? All I want is what is m and what is c. And the last one, I'm back to watch it. All right, let's see what you got. Right, so the first thing I would do is I would write 3y is equal to 6x plus 9. Put it in the form y is mx plus c. And then I would divide everything by 3. Right? So now I will get y is equal to 2x plus 3. Right? So now I know that my gradient is 2 and my y-intercept is 3. Huh? Ready? That's simple. That I'm done with all. Right? So that was nice. Answer is 2, 3. If I could show. Right? Do I want to show entire past paper? Let's try the past paper. All right. So I'll give it that. I forgot to give you something about gradients. Right? I forgot to give you one thing about gradients, right? Right? One little thing that we need to know about gradient. We have 2 types of lines that we're going to focus on. Parallel lines and perpendicular lines. Right? Perpendicular lines means the lines meet at 90 degrees, right? So if I give you 2 parallel lines, and you have 2 gradients here, and you have 2 gradients here, the nice thing about parallel lines is that the gradients equal, right? So whenever they tell you 2 lines are parallel, it means that their gradients are equal, right? If they tell you 2 lines are perpendicular, it means that when you multiply M1 and M2, you're going to get -1, right? So these are 2 rules you have to learn. And if I ask you to find M2, M2 is -1 on M1. right? So I forgot to give you this under gradient. If you can squeeze it in, otherwise write it out, right? So there's two little rules that you need to know about gradient. So let's copy down those two little rules there. And let's see if we can apply it here, right? Let's see if we can apply it here. So in example one, I have two parallel lines, right? I have two parallel lines, but I have no idea what the gradient of the second line is. Alex, I need some help. Right? Here, in example two, right? In example two, I have two perpendicular lines. I have two perpendicular lines, and I don't know the gradient of the second line, this line here. I need some help. I will go to Nathan. Right? So Nathan, I need some help on how to get this gradient. And Alex, I need some help to get this gradient. Wait, no, can you already say it? Okay, Isaac. Isaac, I need some help with this gradient. To figure this out, you have to use those rules, right? I'm not giving you an example. See what you come up with. Take your time. And so something right. Right, so here's what Isaac did, right? Isaac made y the subject of the formula here. He divided by 3. And he got 2x is equal, sorry, 2x plus 12. So it means that the gradient of this line is 2. And the lines are what? The lines are parallel. So therefore the gradient is same thing. Right? Good job. Who turn out? Nathan. Yeah, Nathan. So first thing, Nathan, what is the gradient of this line here? 2. So the gradient of this line is 2. These two lines are what? Perpendicular. Nice. How we getting this, right? Look at that little thing I give you there. Gradient here is 2. Use this. What I will give you. You can do it in your head. Huh? -2, for sure. And says -1 on next gradient. So it's -1 over the next gradient. So it's -1 over the next gradient, which is 2. That's it. -1/2. Okay. This is also called negative reciprocal curvature, right? What they do is they flip this value over and they change the sign. It's called negative reciprocal. Okay? So they flip this value over and change the sign. Are you okay with that? Yeah? So that's the way you find gradient, right? Alright, I'm going to show you that because I did not give you that level yet. Now we can take a little glance at the question. Alright. You'll see it there. That's question 1. They want you to find the gradient of line 1 and line 2. I think best I can kind of back up a little bit again. Better? Yeah. So find the gradient of L line 1 and line 2. Right, but without working it out scenario, L1 will be a positive or negative gradient. And Vishish, without working it out, L2 will be a positive or negative gradient. Negative. Okay, go ahead. We're working it, Jamal. Jamal, you're in school now. No? Sorry. No. Not at all. Right? So pick any 2 points you want, right? You can pick any 2 points you want and find gradient. Right? Like pick on somebody online to send their gradient. Oh, okay, Maria. That's just now. Right, let me pick on the quick on here. Who's the quick on here? Bandana. Bandana, send a gradient for L1, right? right? Find the gradient for L1 and the gradient for L2. Right, so banana, all you have to do is just pick 2 points, right? So you can pick this point here and pick this point here and find gradient. So for example, if you choose this point here, that point is 3, 7. You'll see that? 3, 7, right? You just read the top. And this point here is 5, 11. Right, so use those 2 points, quick bandana, and find the gradient. Right? Remember it's a graph, right? So you just read the points of the graph. You guys from both of them, right? While you're waiting, try to see if we can figure out how the two lines related. Right? Find the gradient, quick banana, how waiting on you. Bandana, and your value. What's the formula for gradient, bandana? Check back your notes. Check back your notes and the formula for gradient. Right? And once you see that, all you have to do is just plug in x1, y1, x2, y2. Just plug in those points quickly. not paying attention. Huh? So gradient is equal to y2 minus y1 over x2 minus x1. So that is 11 minus 7 all over 5 minus 3. Right? 11 minus 7, but 4 over 2 is 2. So that gradient is 2. And then we can do the same thing down here. We can do the same thing down here. I will choose, it don't matter what point you choose, but I will choose 0, 6. And here, I will choose 12, 0. Right? And we're doing the same thing again. Y2 minus y1 over x2 minus x1. So I will say 0 minus 6 over 12 minus 0. I got minus a half. Right? Right. You're not seeing it, but the question asks, what is the relationship between line 1 and line 2? Remember, gradient here is 2, gradient here is minus a half. They are perpendicular. How do you know that? How do you know the perpendicular? No, but it can be at different, it could be 9, it could be 89 degrees. It could be 87 degrees, it could be 91 degrees. How you know the perpendicular? Mandina, how you know that those two perpendicular? Right? One creates the negative reciprocal. So basically, here's how you know that. If you were to multiply both gradients, what you'll get? What is 2 by minus a half? Minus 1. Right? So what's the rule, Kashish? The rule is when you multiply M1 and M2, you will get negative 1. So when you multiply gradient 1 and gradient 2, you will get minus 1. Okay? Vandina, follow that now. Are you okay with that? All right, Maria. All right, so you need to remember that, right? Right, let's go again. Right, that's the best I can do there, right? June 20. Wait, no, no. That's not. I have it zoomed in. That's not. One on top there, right? June 2013. Right, so they wanted to get the gradient, then they wanted to get the coordinates at the midpoint, and then perpendicular bisect. I'm not sure if you'll ever heard that word before, right? But if I give you a line, perpendicular bisector means it's going through the midpoint, 90 degrees. Right? Perpendicular bisector means it's going through the midpoint at 90 degrees. Okay? So if you're not getting part 3, that's right, I'll help you. But try to get, you should get part 1 and 2. Give me a few minutes, I'll pass around what you get now. I type part 1 and 2. Right, message your answers there. I'm Kaya, Arissa, message your answers. Finish already? David? Part 1 and 2, finish it? Alright, try part 3. This perpendicular bisector means it's going through the midpoint. Last thing to do, right? Right, next day we'll continue with some of these, right? Some of the harder ones. I have to remember all the rules. Right, so I'm checking it part 1 ingredients. Right, so the ingredients is y2 minus y1, y2, y1, x2 minus x1. So I got minus 2 and 4, which is minus a half. Anybody else got that? Ingredient? Yeah. Then let's find the midpoint. The midpoint, that's part 2. The midpoint is equal to x2 minus adding up the x values and adding up the y value. Right? So I'll end up with 2, I end up with 1 3. But yes, got that? 1 3. All right, good. So I want to help you now figure out this perpendicular bisector. So think about it like this, right? Let's say we had a line and we had AB on the line. right? Here's what they want. They want a new line, right? They want a new line that passes through the midpoint of A and B and is perpendicular, right? We found the midpoint already, and the midpoint is 1, 3. So we're using 1, 3 as X and Y. And we know the gradient of AB is -0.5. Remember, perpendicular bisector means at 90, right? So therefore, anybody can tell me what's the gradient of the red part? Let's pick somebody. Who might pick one? 30. The green line has a gradient of -0.5. What do you think is the gradient of the perpendicular red line? Well, whatever color is that? Oh, let's see. Well, listen. One is -0.5. What's the next one? If they're perpendicular. The perpendicular here. One is -0.5. So what will be the next gradient? We did one. No, the gradient of the first line is -0.5. Right? What's the gradient of the perpendicular line? Make it help up. It'll be 2. Right? Negative reciprocal. Look at one on the board. Right? And the gradient here was -0.5. And the next one was 2, right? So the gradient of the red line is 2. Okay? David? Papa, tell me. You sure? So how do we find C now? C is equal to y minus mx. Right? Y is what? Y is 3, m is 2, x is 1. So when you work it out, you will get C is 1. All right? So your final answer is y is equal to 2x plus 1. That is the answer for the perpendicular bisector. Okay? Hold on, let's line and see. Be back. 30. Come on, slap a little closer. You want fish. Right? Next time. Okay? So again, to find the equation of a line, all we need is the point on the line and the gradient. All right, so make a note of that this. To find the equation of any line, make a note of that, right? To find the equation of any line, we need a point on the line. We need a point on the line. And the gradient of the line. All right. So next day we'll continue with this, right? So please go over it, do something, right? Go over these formulas, make sure you remember them. All right, so we'll continue from right here. We'll do a couple leaves here and then go into the algebra.